Welcome to this explainer. All right, today we're going to completely destroy this persistent myth that sleep is just some passive state of rest. For decades we've kind of thought of sleep as just powering down, right? Like closing the lid on a laptop. But the biological reality, it is vastly different. Sleep is actually an intensely active, highly orchestrated maintenance system. It's this absolutely crucial period where your nervous system regulates itself, your metabolic health gets calibrated, and literally, your brain undergoes physical restoration. We are going to unpack exactly how this hidden architecture works.
Just to give you a sense of the ultimate biological payoff we're building toward here, consider this. Your brain actually lacks a traditional lymphatic system to clear out waste. Instead, as Dr. Meyer points out, it relies on what he calls a night shift cleaning crew. Seriously, it's wild. We're going to progressively uncover how sleep acts as a literal mechanical pressure wash for your brain, clearing out all those toxic proteins. But to get to that nightly pressure wash, we first need to understand the master switch that controls the whole shebang.
Okay, let's dive right into this with Section 1, the brain's master light clock.
So the master environmental controller of your sleep architecture isn't actually something you do at night at all. It's what your eyes are doing during the day. Now, for a long time, we thought the eye only used rods and cones for vision, but researchers stumbled onto a completely different class of cells called iPRGCs. These make up just like 1 to 3% of your retinal cells, and they are autonomous irradiance detectors, meaning they don't help you see shapes or colors, they basically act as a light meter for your brain. They use a specific photopigment called melanopsin to absorb short wavelength blue light, specifically right in that 460 to 480 nanometer sweet spot, and then they send a direct neural signal straight to the brain's master clock, the suprachiasmatic nucleus, or SCN.
And this creates just a brilliant day-night biological toggle. During the day, that melanopsin activation signals the SCN to actively suppress the pineal gland via this complex multisynaptic circuit. Basically, it keeps your melatonin at zero while boosting cortisol and body temperature to keep you alert. But as darkness falls, those iPRGCs, they stop firing. And this relieves the SCN's inhibition, allowing your pineal gland to finally synthesize and release melatonin. It's just this beautifully precise mechanical switch.
So how fragile is this switch? Well, think about the number 100. A landmark study found that sleeping with just 100 lux of artificial light, which by the way is roughly equivalent to just a dimly lit room, is enough to artificially activate your sympathetic nervous system while you sleep. No way, right? But the next morning, these participants woke up with measurable insulin resistance. Their bodies literally couldn't process glucose properly because their autonomic nervous system was trapped in daytime physiology all night long.
Which brings us to Section 2, the downward sleep substance spiral.
Now, we know light interferes with our biological clock, right? But we also chemically interfere with it every single day. Let's look at the two most common psychoactive substances in the world, caffeine and alcohol. Caffeine operates as a high-affinity antagonist for adenosine. Adenosine is the chemical that builds up in your brain to create sleep pressure. So by blocking it, caffeine destroys your ability to initiate sleep and depletes the sleep sigma brainwaves you desperately need for memory consolidation. But Alcohol is highly counterintuitive. It actually increases your early slow-wave sleep or deep sleep. But, and this is a massive but, it catastrophically destroys your REM sleep and drastically fragments your overall sleep architecture.
And this creates a vicious, self-reinforcing downward loop. Because caffeine delays sleep, people often use evening alcohol as a sedative to, force sleep onset. And sure, the alcohol works initially, putting you into that early slow-wave sleep, but it completely ruins the restorative quality of the night. So you wake up absolutely exhausted, dealing with severe psychomotor deficits, which then forces you to rely on massive doses of caffeine the next day. And the spiral just continues, fundamentally and frankly, catastrophically degrading your neurobiology over time.
Moving right along, let's hit Section 3, autonomic control and vagal rebound.
So, how do we actually break this chemical cycle? Well, we need to transition from chemical interference to the physical levers we can pull to regulate our autonomic nervous system. We literally have to actively push the body into parasympathetic dominance to prepare for deep sleep. One of the absolute best, most evidence-based methods for this is Jacobson's progressive muscle relaxation, or PMR. The mechanics here are highly specific. You move from caudal to cranial, so feet to face. You forcefully contract a muscle group to about 80% capacity for exactly 5 seconds, and then gradually release and relax it for 10 seconds.
This mechanical contrast physically reduces muscular tension, which then inhibits the pituitary-adrenal axis, driving your heart rate variability way up and practically forcing the nervous system into a relaxed, parasympathetic state. And the data on who benefits most from this physical lever? It is fascinating. In a study of recreational athletes performing this exact PTMR protocol, researchers measured a marker of vagal or parasympathetic rebound. Now, you'd probably expect the normal weight athletes to perform better here, right? But actually, the overweight individuals exhibited a much stronger short-term parasympathetic rebound. Why? Well, because they had a lower baseline vagal tone to begin with, giving them a much greater biological margin for improvement. It just goes to show that targeted relaxation works exceptionally well for those whose autonomic systems are the most stressed out to begin with.
All right, let's jump into Section 4, Exercise, Temperature, and Sleep Architecture.
So, along with relaxation, the timing of our daily physical stressors, like exercise, fundamentally alters the actual structure of our sleep waves. Polysomnographic research reveals that 60 minutes of vigorous exercise dramatically increases delta wave power and really stabilizes your deep slow wave sleep. But timing is everything here. Morning exercise at around 7 a.m. triggers the absolute best cardiovascular recovery and sleep expansion. But if you exercise vigorously at 7 p.m., you elevate your core body temperature and your cortisol way too close to bedtime, and that directly blunts your body's natural melatonin rhythm.
And listen, temperature is absolutely non-negotiable. To even initiate sleep, your core body temperature must naturally drop by roughly 2 degrees Fahrenheit about 2 hours before bed. Your body does this through something called cutaneous vasodilation. Basically, it pushes warm blood out to your hands and feet to vent that heat away from your core. If you exercise too late or even eat a massive meal too late, you trap that heat in your core, and the biological sleep sequence simply cannot begin. Which brings us to the grand finale. Section 5, the brain's nightly cleaning crew.
All of this stuff we've been talking about, the light management, the nervous system regulation, the core temperature drop, it all serves to set up the brain's ultimate physical maintenance phase. Enter the glymphatic system. Discovered back in 2012, this is literally a specialized macroscopic plumbing network inside your brain. It utilizes these things called aquaporin-4 water channels, which are located on the end feet of cells called astrocytes. During deep sleep, cerebral spinal fluid is powerfully pumped through these paravascular channels, physically flushing out the metabolic waste that your brain accumulates during all those waking hours.
I really want to let this visceral biological reality sink in for a second. When you enter non-REM slow-wave sleep, your actual brain cells physically shrink, like they actually contract to open up the interstitial space between them. And this allows that clear cerebral spinal fluid to wash through like a high-pressure hose, clearing out toxic neurodegenerative waste proteins, specifically stuff like amyloid beta and tau, which are the exact proteins linked to Alzheimer's disease. If you don't get deep sleep, this nightly pressure wash just simply does not happen. So, to run this brainwashing cycle optimally, here is your exact biological framework. First, you need uninterrupted NREM slow-wave sleep. Fascinatingly enough, research indicates that sleeping in a lateral, or side-sleeping, position actually optimizes the physical drainage angles of this fluid. Crazy, right? You also need strict circadian alignment so those hormonal cues fire exactly when they're supposed to. And finally, you absolutely need a regulated autonomic nervous system to keep neuroinflammation low, ensuring those channels aren't blocked up.
We've seen how artificial light breaks the master clock, we've seen how substances spiral us into fragmentation, how muscle relaxation acts as an autonomic brake, and how it all culminates in literally shrinking our brain cells to wash away toxic waste. Sleep is not passive, guys. It is a highly engineered, intensely active state of survival and optimization. So, knowing all these hidden levers you can pull, how will you engineer your biology tonight?